Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, some time ago, I produced a video on a topic about indeterminate forms, and I was asked some questions about it recently, so I'll go through the reasoning and the background to that with you now. Let's begin. So, here's the first slide that I had. I said, consider the following valid algebraic equation. Okay. And I called it AE. Those idiots who teach you mainstream mathematics will tell you that x is not equal to minus 2 and x is not equal to minus 3. And the morons will wax eloquent telling you that x is not equal to minus 2 and x is not equal to minus 3. And let's see, so how did I get that? Well, that's very easy. Look, so what you have here is you've got the basic equation, x squared minus x minus 6, right? Which is equal to, that's the left side, 6x actually. In fact, here, let's do this. Let's just copy it from and then I'll explain it because I don't want to have to remember it. So what we've got here is this. Let's print this. Come on, let's go. Okay, so we've got that. Right, so all you have to do is basically just multiply by what's on the bottom here because it has to be a number, right? So if you do that, then on the left-hand side here, you'll get x squared minus x minus 6. That's this times x. And on the right-hand side, you'll get 5 times x squared minus x minus 6. And if you multiply those out, you'll get, and rearrange the terms, you'll get this, right? Simple as that. Now, if you plot that in GeoGebra, so let's do that. Let's plot that in GeoGebra. Let's say f of x is equal to x cubed minus 6 times x squared. Whoops. I think I had to go down there. Okay, x cubed minus 6 times x squared minus x plus 30, right? And what you'll have is a curve like this. And the fools, who are your teachers, will tell you that x is not equal to minus 2 and 3. So let's see. F minus 2 is 0. So it has a no number solution. And F3 is also 0. So it has a solution. You see, look there. There's a solution there and there. So obviously what they're telling you is a load of BS, because when you treat expressions correctly like this one, you're not going to end up with garbage. Okay. So there's no way you can put things in here. You don't put things in X. Okay. You treat the whole expression as if it were a number. Naturally, there's no way that in this particular form you can say x is equal to minus 2 or x is equal to 3. You don't put values in x. You solve for x. Okay. So if in an equation like this, if you put values in there for x, you're going to get garbage because 0 is not a number and you cannot divide by 0. Okay. Why? Because 0 is not a number. Yes, that's right. It's as simple as that. So you get this, and then finally you have these roots, and it turns out that x is equal to minus 2 or 3 or 5. And the truth is, when mainstream math apes like your teachers and your lecturers, when they try to do mathematics, they do caca, okay? So, because when one treats factors as numbers, not indeterminate forms, there's no such thing as an indeterminate form. It's bullshit. Then algebra produces correct results. And who would have known? Yes, I know better than you stupid apes. Another thing I'd like to bring up, which is along the lines of this topic, is that if you go to any AI and you ask them about the new calculus, they'll tell you the new calculus doesn't allow you to find the derivative. Yes, it does. And in this historic geometric identity, which states this, what I, the great John Gabriel, am telling you is that this finite difference contains both of these, and I prove it in my article called The Historic Geometric Theorem. Now, this isn't new calculus, by the way. This is not new calculus. It is realized from it. The new calculus is 100% better than this, and it doesn't have uh, a slope difference like you'll have here all the time, except in the case of a straight line. In the new calculus, this slope difference is always zero. And it's one of the powerful features about the new calculus derivative this year, which, by the way, is not what that idiotic fucking idiot Professor Jack Hasinger from Illinois thought. Okay. It's not the central difference. This here is equal to f prime of x. And it doesn't matter if you add q, x, mn, because this is always zero. So this historic geometric identity was realized when I tried to see if my 100% rigorous new calculus could be used to fix your bullshit mainstream calculus. And yes, it can, but this tends to get quite messy when you want to work with the integral. Okay. And the new calculus isn't as messy, but still, you get very good results because your integral from x to x plus h of f prime of x dx is equal to h times f prime of x plus q of xh. You don't believe me, morons? Try it out. Try it out, you idiots. Try it out. Don't believe me. It's fine. If you're not already a subscriber, become a subscriber to my channel. I do know better than you. You can also follow me on academia. I'll place a link to this article on academia so you can download it free. I know better than anyone else. That's not an opinion or an assertion. It's a fact. You can also join my members only channel where you learn a lot more than I share with the public. Okay. How do you do this? Do you see this little join button here? You click on it. For $4.99 a month, 4.99 euros a month, you have access to a lot more than what I've just shown you. Well, I'm a little tired now, and it's getting late. Have a good night or a good morning. I'm John Gabriel. Till next time, goodbye.